Good morning, Shruti. Am I audible?
Yes, sir. Good morning, sir.
Just wait few minutes for rest of the students, then we will start the session. Okay.
Yes, sir.
Okay. So let's start the session. I think no one will join. Uh, so uh, in the last class, what topic we covered? Who was present in the last class? You don't know in the last class what topic is covered? No one has no concept.
सर एटेन्यूएशन एंड फाइबर करके कुछ न्यूमेरिकल्स सब हुआ था फाइबर लॉस का न्यूमेरिकल्स
So in that class, we discussed some numerical about the firewall loss and we discussed the attenuation. So what are the parameters actually affect the or create the attenuation? So in that class, we discussed the absorption, the category of absorption. Okay, these are the category of absorption, and we also started the scattering loss and the bending loss and clay and cladding loss. So these are the four losses in the category of in the subcategory of attenuation. Okay, so can you tell me what is absorption? What is absorption? In the last class, we discussed what is absorption and the category of the absorption. What are the causes for this absorption in optical fiber communication? Okay, so first I will briefly introduce the uh, previous topic, then we will start the session, the next topic. Okay, so absorption loss, mainly it is related to the material composition and the fabrication process of the fiber, and we discussed that there are actually three types of absorption, or absorption is caused by the three different mechanisms. First one is the absorption by atomic defect in glass composition. Second one is the extrinsic absorption, and the third one is the intrinsic absorption. And in that class, we have also discussed this one by one. So this is the absorption. Now we will discuss the scattering. So scattering, first is, what is scattering? Anyone has any concept? What is scattering? What is scattering? In simple way, you can say when the light is traveling in that sense, or in that propagation, if there is any obstacle, so due to this obstacle, the propagation or on the way of light is changing in scattered manner. Okay, the way of traveling of light is changing in scattered manner. This is called the scattering. Okay, and this scattering loss is occurred in optical fiber communication channel. And actually this scattering loss exists in optical fiber because of microscopic variation in the material density and composition. Okay, and actually we discussed the two scattering. One is Rayleigh scattering and another is Mie scattering. In this topic, we already covered in the last class. The first one is, what is Rayleigh scattering? Rayleigh scattering of light is due to the small localized change in the refractive index of the core and cladding interface or material. And there are actually two causes during the manufacturing of the fiber. The first one is that due to the slight fluctuation in mixing of the ingredients, and the second one is the slight change in density as the silica tools and solidified. So these are the main two reasons for the Rayleigh scattering, and another is the Mie scattering. Okay, and also we have discussed one formula, that is the scattering loss for single component glass. Now we will discuss, that is the bending loss. We also started in the last class what is bending loss. So before going to start the bending loss, yes. Okay. Yeah, I think now the screen is visible for all of you. Bending loss.
Yes, sir.
Okay, so bending loss here Actually, I am drawing a figure for your better understanding. Just 1 minute. In the last class, we also draw the figure. Suppose like that. This is escape today. So here actually the bending losses due to the curvature and the losses caused here by an abrupt change in the radius of the curvature, that is actually referred the bending loss here. So here you can see in the optical fiber core, the light is moving in the core here and in the normal direction, and here the actually in this curvature actually the moving light is reflected in a different manner. Okay, and here the sharp bend of this optical fiber causes the significant radiative loss, and there is also the possibility of the mechanical failure also. Okay, and this actually the radiation loss occurred, whatever the radiation loss occurred in this core part from the bend, it is actually depends on first, that is the field strength. Okay, first is field strength, and the second one is the radius of curvature r. Okay, so this radiation loss from the bend here, it is depends mainly these two field, that is the field strength where the power is lost through this radiation, and the second one is the radius of curvature. Okay, now for the case of multi-mode fiber, I think you already know what is single mode and what is multi-mode fiber.
Yes, sir.
Okay, so for the case of multi-mode fiber, actually, the effective number mode that can be guided by the curve fiber, curve fiber. Okay, so it has an expression. Okay, so directly I am here writing the expression. So the expression is that just 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 give me 1 minute. So the here the formula is in effective equals to n lambda 1 minus alpha plus 2 divided by 2 alpha del 2a by r plus 2 into Kr divided by 2 by 3. So here the alpha is the graded index profile. Del is the interface, that is core cladding interface. N2 is the refractive index of cladding. K is the wave propagation constant. And this is the total number of mode in Del fiber. Okay, so this is the concept about the bending law. Okay, now based on the curvature, these bending laws are it broadly classified, that is the two category. One is micro bending and another is macro bending law. Okay, so first one is we will discuss, that is the micro bending laws. So for the term of micro means what?
Sir, very small.
Yeah, micro means very small. Okay, so here you can see the slide is for the micro bending law. Yeah, so the micro means the very small. So micro bending loss is a loss due to the small bending or the distortion. Okay, and one thing that this small micro bending loss is not visible, and the losses due to this are the temperature related and tensile related or the crush related. So these are the reasons for the micro bending loss. Okay, so micro bending loss we cannot visible, and mainly the temperature related and tensile related and crush related is loss is called the micro bending loss. So here you can see there is a loss in this core cladding interface, and the second one is the macro bending loss. So macro bending loss. So macro bending loss means macro means hello.
Sir, very large.
Yeah, macro bending loss. So macro bending loss are caused by the large scale bending of the fiber. Okay, so in this figure you can see there is a large scale bending in this fiber, and one thing, the losses here the eliminated when the bends are uh, strengthened, and the losses can be minimized, not exceed the long term bending radiation or radius. Here you can see this is a core cladding interface, and here the due to this macro bending loss, there is a power loss through this radiation also. Okay, so this is the concept of macro bending and micro bending loss. So now I am requesting you, all the participants, write your name in the chat box for the attendance for the first session. Then we will discuss the next topic. Okay, so the next topic, all of you already given the attendance. 1, 2, 3. At this moment, there is 7 students. Everything. Okay. So there is another loss, that is the core cladding loss. Core cladding loss at this moment, it is not in the slide. I will try to describe you by whiteboard. Okay. So first one, the core cladding loss. Here I am writing just, core cladding loss. Okay. So, what is core cladding loss? So, before going to start the explanation about the core cladding loss, here I will draw the optical fiber core cladding interface. This is light. This is the core part, and this is the cladding part. This is the you can say the core axis. So here for this core cladding loss, actually the core cladding has the different indices of the refraction. Okay, and they have the different attenuation coefficient. So here it is written, that is the alpha 1 and the alpha 2 respectively. Okay, so for the step index fiber, just 1 minute. For step index fiber, or step index fiber, the loss for a mode order is p comma a is given by alpha pm equals to alpha 1 p core by p plus alpha 2 p cladding by p. You just remember this expression, this core cladding loss. So if you will get any question regarding the core cladding losses, so in that sense you should write this equation. Okay, and for the for low order modes, the expression reduced to of m equals to alpha 1 plus alpha 2 minus alpha 1 p cladding by p. This is the equation number 1, and this is the equation number, sorry, this is the 2 and this is the 1. So where here you can see the p core by p and p cladding by p. So what is this? Actually, P core by P and P cladding by P are the fractional pores. And for graded index fiber, okay, for graded index fiber, loss at radial distance R is expressed alpha 2 minus alpha 1 n square 0 minus n square R given by n square 0 n2 square. This is the equation number 3. And the last equation, okay, the loss for a given mode, actually for the graded index, the equation I am writing in the top position. Okay, so alpha graded index this is integration 0 to infinity alpha R P R R dr divided by 0 to infinity P R R dr. This is the equation number 4, where PR is the power density of that mode at radial distance R. Okay, so for the case of core cladding loss, you just remember this equation. If you will get any type of question regarding the core cladding loss, in that sense, you have to write this equation. Okay, so the core clad, the losses is complete. That is the these losses actually actually affect or actually create the attenuation. So core cladding loss, scattering loss, absorption loss. So this topic already covered. You have any query? If you have no query, then we will proceed for the further topic. You have any query or not?
सर पी कोर एंड पी क्लैडिंग ये फोर्थ से है क्या?
P core by P and P cladding by P. These are the just these are the fractional pores. Okay, fractional powers here you can say. So there is any other question? And yes, you already asked the notes. Okay, and I will upload tomorrow all the video link in the Google Classroom, and as well as I will share the notes for your examination. Okay. Okay, so now I am erase these things. Now we will discuss the distortion, signal distortion in optical waveguide. Just 1 minute. Yeah. Okay. So now we will discuss or focus about the signal distortion. So before going to start the signal distortion, we will discuss first two topic. One is the uh, information capacity determination, and the second one is the group delay. Okay, so after that we will discuss the dispersion. What is dispersion actually? So before going to start, also the information capacity, sorry, information capacity determination. So just 1 minute. Okay, so first of all, what is dispersion? When we 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 are giving the light waves in the optical fiber, so this light waves actually a signal, this in the form of light waves, it is traveling from transmitter end to receiver end, and there is n number of signal. So it may be distorted when it's traveling in the optical fiber channel. So the pulse get distorted as it travels along the fiber length, and here the pulse spreading in the fiber is referred the distortion. Okay, so normally when it is spreading in a optical fiber channel, actually it refers the dispersion, and this dispersion is caused by the different in propagation times of light rays, and that takes the different path during the propagation. And one thing for the case of a dispersion, actually, so dispersion process limit the information bandwidth, and you can easily understand how it is limit the information bandwidth, because well, if there is a spreading, so dispersion is occurred. So if the dispersion is occurred, so there is a error, you can say, in the um, channel, and it creates the limitation for the information bandwidth, and that these dispersion effects can be analyzed by the studying of group velocities in the guided module. And for this we will discuss first the information capacity determination, and the second one is the group delay. Okay, so before going to start, just give me few seconds to draw the figure for your better understand. Almost 5 minutes left for the session, but if I will start the drawing here, so I think we will not continue in the second session. So I am just ending here the first session, and you just join the same link with the for the second session. Okay, I am just ending the session here for the first session actually, and after 5 minutes you just join in the second session with the same link.